different way to record audio. We'll see. It looks hideous, but I moved it up and changed the setting. Hopefully it's less scratchy. So, the average score is 66, which is actually pretty good because I had one wrong. So you would add 20% of that. So the average score is actually 86% on this quiz. So that's really good. Uh-oh. I don't know if I can do that. There we go. So 89% got this right. So what's the exponent for NH3? It was a 1. We need to change a little bit of our language, by the way. Not change it, but let's learn something here. If the exponent is a 1, another way of saying that is that NH3 is first order. That's the way the book's actually going to ask it, or the AP test. If it was a 2, you'd say it's second order, or it's third order. You okay with that? It's just a different way of saying the exact same thing. All right, the 2 that didn't get it, we can still probably be friends. For some reason in this program, my thing doesn't scroll very well. It's extremely annoying. Let's just move that way. Coming down here, good. Everyone got this one was first order as well, except for 1. And then coming down, I have no idea. I mean, it's on my calculator. It's 3.408 or something like that. But I put 0.3408, being dumb. So most of you probably got that right. And then the proof is in the pudding. If you have this one right, you had to have that one right. So this one, it was just asking for the rate. So you just plugged everything in. Everything was raised to the first, so math-wise it was pretty easy. You multiply K times the 2 concentrations I gave you, and you ended up with whatever, I don't remember the range, the exact answer there. But overall, this is a pretty good score. So hopefully you feel comfortable with these problems. This one is a homework question that was in the lab, or in the textbook, if you are people that do homework problems. So far I'm up to 4 people that have submitted their blue sheet. 1 was printed and turned in yesterday, and 3 were submitted online on Canvas. Either one is just fine with me. Your answers seemed way more technical, so I think maybe the cut and paste button was effectively used by a lot of you, which is fine. All right? You didn't even think about it. Well, that's okay if you didn't think about it. Yeah, you had to read it when it turned blue to cut it, right? All right. So let's attack this. So the next thing we have to do is completely different. This is a way different way to do the exact same thing. What? It's up to you. I think I'm pretty good at seeing a problem in my eyes the other way, like I can do it really fast. This one is fine, it just takes a little longer for me. But if you really like your calculator, then this one's way easier. Alright, before actually I go there, let's talk about that quiz question again. When you got this, you had rate was equal to K BF3 to the first NH3 to the first. I haven't used this vocabulary very much, but I really do need to, and you need to be able to too. So you, if asked, you would need to know that BF3 was first order. NH3 was first order. I don't know why I just put a 2 right there. It was first order. Actually, I do know I put a 2 there. But sometimes they'll ask for the overall order of the reaction. To find the overall order of the reaction, you add the 2 exponents. So this is a second order process or a second order reaction. You okay with that? That was in the reading, but that's super important for us. So to find the individual order of reactants, you just know the exponents. To find the overall order of the reaction, you add the exponents. In this class, we usually have a first, second, or third maximum order. And there's a reason behind that. It's because 99% of chemistry is going to be a first, second, or third order process. All right? And we'll explain what order means in a day or two in detail. Essentially what it means is how many things have to collide at the same time. And if 3 things have to collide at the exact same moment in time, it's getting a little bit harder to have a reaction actually happen. So if 1 just has to break apart, that's easy. Or if 2 have to run into each other, that's usually not very hard either. Okay, good-ish. Make sure you're okay with just that type of vocabulary. All right, now, this type of question we've been doing is called initial rates. And usually it's given to you in a table. All right, so you'll have a data table that looks just like this one. You have a series of experiments, your initial concentrations in the experiment, and then they find the initial rate. When you are given a table like this, you need to do the process we have been doing. You find what's the same, what changes, and see how it affects the rate, and do the math. And overall, I think we're rock solid there. So now we'll introduce what we call the integrated rate law. All right? Where we apply calculus. Now, we're not going to do the calculus, but if we applied it, when we use calculus to integrate the rate law for a first order process, it gives us this. And it was really ugly the way that it was done. Let me just cover that up with a white rectangle and life will be easier. There we go. So that is what the integrated rate law, if we put this through some calculus, we generate this. That negative KT equals the ln of A concentration at a time divided by the concentration of A at time 0. Okay? Naught means time 0, which would be your initial. Okay, I gotta move because this isn't reading it for some reason. That chicken scratch is supposed to say the word initial. What's that? Yeah. So it just says it right here. A naught is the initial concentration of A. AT is the concentration of A at some time during the course of the reaction. All right. Now, this is an equation that you have to be able to use. It will be given to you. It's given to you usually in a little bit different form, but whatever, it's just calculus. Or not calculus, it's just algebra here. When you divide, by the way, in an ln, it's the same as the ln of AT minus the ln of A naught. That definitely might be something that's important. Did I say that right, math people? Okay. All right. So, manipulating this equation gives us all this jazz. All right, so this is just, we're now just doing algebra. We're rearranging it. Like I said, LMAT over that ends up being subtracting that, and that's a lowercase. That's not a 0. That just means that A time naught equals negative KT. All right, manipulating it a little bit more gives you this form of the equation. Now, you don't need to know much from this page, but if you look at this formula, we have ln of AT equals negative KT plus ln of A naught. This, even though it's hideous, it might not look like it, it's in the form of y equals mx plus b, and y equals mx plus b is the equation of a line. You all right with that, sort of? Okay. Yeah, we're getting there. This is like the reason why what we're about to do is going to work. Therefore, if a reaction is first order, meaning the exponents are 1, a plot of ln of the concentration of A versus T will yield a straight line, and the slope of the line will be negative K. All right. That sentence is super important because we're going to use our calculators and some data to graph a line. If we graph the ln of A versus time and we plot it and it's a straight line, then we know that A's exponent in the rate law is a 1. We also know K now because the slope of the line is equal to negative K. So K is really the negative slope, if you want to look at it that way. All right. Let me know when you have that sentence written, if you're writing it. What we've done the last 2 days is use data tables to figure out the exponent or the order for each reactant. Here, we're going to use graphical analysis to do the exact same thing. Now, we will still be given data tables, but they're a very different data table. All right, so whatever, nothing important on this slide. It's just saying, let's think about this. All right. So this data was collected for the reaction at 198.9 Celsius. Now, this is the pressure. So what you're typically going to be given is the change in concentration or the change in pressure, which they have torr here. All right? Now, it's weird, but concentration is brackets. If they're doing this for pressure, they just generally draw parentheses. It doesn't really matter. But you'll be given a data table of the change in these versus time. Now, that data is nice, but that's not necessarily what we're looking for. If you look and see, remember, we're looking for a slope of ln of A versus time. Okay, so that will be the next slope. So this is the change over time. Here, we just use the calculator to take the ln of each value, and we plot it versus time. When we take this line and we do the natural log of it, and we plot that data versus time, we ended up with a straight line. Since this line was straight, that indicated to us that the decomposition of CH3NC was a first order process. Now that I know it's a first order process, I can find the slope of this line coming down here, and the slope of the line will be equal to negative K. All right? So we know K is going to be a positive value, but we know this slope is a negative value. That's why this is a negative. All right? If we put this in our calculator, K ended up being the negative slope of 5.1 times 10 to the negative second. Seconds to the negative 1. Now, our calculators will do this process for us if we know how to use them. And it's not hard. Okay. So this is what we need. Everyone, if you have access to one, you need a TI 80 something. All right. So take that out. I still probably have some loaners around the room somewhere. And let's learn this process. So on your TIs, you just turn it on and then hit the Stat button. And then you should be highlighted on Edit. And if you just hit Enter, you're now going to have L1, L2, L3, and it just keeps going. These are lists. Now, it wouldn't surprise me if you borrowed one of my calculators, there's already numbers there. Did anyone have numbers already? Okay. If there's already numbers there, I would encourage you to always delete every number. Because if you just type over and you ended up On the last one, there was like a 7.5 and a 2.8, but you don't type over or delete those. That will screw up all of your data. Does that make sense? I would delete every number. Okay, so in L1, all you do is input that data right there. So you got your 0, your 0.6, and you don't need to have me talk. I'll go ahead and put those in. All right, and your 2.4. And then in L2, you put that data in. This is one of my favorite tests to give because the sound of the calculator buttons just going crazy. It makes me feel alive. It's like the math section of the ACT. It might as well just be a 10-key test. Okay, once you have that in, raise your hand. Next thing that you need to do is you go over to L3 and you're going to define L3 as a function. And you're going to take the ln of L2. So you make sure you're on the top of L3 and the L3 is highlighted and you hit, or once you have that, then you just type in the ln, and then to select L3 you hit second, L2. You hit second and 2. You see how that's blue, most of you? And then just hit enter. Once you have that, raise your hands. If you need help with that problem, it's probably not going to matter, but it will on a bunch. Now that we're here, go to L4 and make sure it's highlighted just like we did before. And for L4, we're going to take 1 over L2. And just trust me, we won't need it probably on this problem, but we will eventually. Okay, and now you have 4 lists. Are we okay with that? Okay, L1 is time. L2 is ln of L2. Okay, that's the ln of your concentration. And L4, or list 4 now, is 1 over that. Okay, now let me pause this and make sure I know what I'm doing. On your calculators, at the very top left where it says y equals, you're going to hit second and then y equal, because we want the stat plot. We want stat plot. Everyone with me? When you hit stat plot, you get 5, or I have 5 on my screen, right? So you have plot 1. Is everybody with me? Okay, so once the 1 is selected, like it's dark, hit enter. All right, and then you have the type, and below that you have the X list and the Y list. Raise your hands if you're on that exact spot for me, so I know we're good to go. Hit second, go back here. Second, Y equals, and now hit 1, it's ready to roll. Okay, raise your hands if you're on that screen. Okay, now, what we want to graph L1, which the X list is automatically L1. You okay with that? But go down to your Y list and then make it equal L3, which you just do by hitting second and the 3 button. You with me? Yeah, if it's off, you need to turn it on. Okay? And then, in type, it doesn't matter really, but I'm going to turn on that one. I'm going to make it actually a line instead of just dots. You with me? It doesn't matter. It just helps you see it a little bit better. Okay, once you have X list of L1, Y list of L2 or of L3, then just hit enter. Or sorry, no, hit graph. Top right corner, hit graph. And then you should have a line. It's most likely going to look tiny. So now hit the zoom button and then push the number 9. Zoom 9 auto fits it to your screen. And then you just ask yourself, you look at it and you say, is that a line? Like, is it linear? Is it straight? Yeah. Okay. But it's pretty close to being linear. Okay. Raise your calculators up so I can see if you have a line. Okay. All right. Zoom 9. Yes, sir. I can check real fast. Okay, does everyone have a straight line? Yeah, I do. Sorry. All right. Now, what in the world does this line mean? All right. We did all that work. We got this graph, right? It just essentially looks like that. It is linear, which means it's first order. Okay? So that's cool. We would now know, what was this? H2O2? Or HO2? We now know that this is a 1. But we also know that the slope equals negative k, correct? Okay, now let me find. So now that we know that it is straight or linear, we now hit the stat button. Okay, when you push the stat button, it gives you the 5 options. You want it on edit. No, you don't, sorry. You want to go over to calc, sorry. So you go over to calc button and make sure that's highlighted. And then it's the 4th one down. So either press 4 or arrow down. And now you have X list, Y list, frequent list, store, reg, EQ, and calculate. We need to make sure that our Y list is L3, correct? Because that's the graph we want to talk about. So it should be L1 versus L3. So again, to change, we want L1, whoops, that's a 1, not lithium, versus L3. To change that, you just hit second, and then 3, and that will put it in as L3. Then keep hitting enter until you get calculated, highlighted, and then press enter. Okay, now, what we did, when we selected 4, we did a linear regression. A linear regression finds the mathematical equation that best fits the line that you just found. Okay, so it's saying y equals mx plus b. The slope is m, right? Now on your calculators, it calls this a, but are you okay with that? So now on my calculator, it's saying that my a value is equal to negative 0.854. Does everyone have that value? Raise your hands if that's the value on your screen. Okay, so we're very close. Is that my slope? No, it's close. What's my slope? 0.854. And I'm ready to roll. No. Slope is equal to negative k. It's okay. So there we have it. 0.854. So now we would know our rate law. Our rate law would be rate equals 0.854. And then it was OH2 or something like that, right? Times OH2. No, I don't remember. Who cares? And it was to the first, correct? We all right with that? Okay, we could use this. We could also plug these values in now into the integrated rate law form. Now that we know K, all right, in the process, we were given A at 0, like in the table, and then we could calculate the concentration of A at any time we felt like it. Okay. Which one? The math? Okay?
You just go the ln of a, then you type t as an actual plot.
No, the t mathematically is actually only here. This is a lowercase t of just saying a at t. Good question. All right, how do we feel about that? Okay. I'll check your calculator. It looks like this is the answer probably to the slope. Will you work through this problem on your calculator? So now, a second order process, if we do the same math and we do all this crap, it also turns in, all right, to a line where y equals mx plus b. I know this is ugly, but just stick with me for a minute. So, here we go. If a process is second order in a plot of 1 over a versus t will yield a straight line, and the slope of that line is k. Alright, so this is very important. So this is why I had that fourth column, or L4. We said L4. Let's put it equal to 1 over L2, because L2 is this value. And that gave us the next set of data that we would need, just in case. So while you're writing, I'll explain. So what we have, if we plot this data, this is a graph, even though it looks more like a T-table. And let's say we did the ln, and it turns out to be curved. All right? That would be L1 versus L3, unless you're the two kids I talked to. All right? So if that was curved, the next thing we would do is go back into our calculators, and we would now change it to be L1. I keep doing lithium. It's a habit. Versus L4. And L4 would give us a different number or line that now would be linear and have a positive slope. Since the slope is positive for this process, k is equal to the slope. Okay? So first thing first, check L1 versus L3, or meaning the ln, to see if it is first order. If it's not, check your second order. If it's neither one, it's going to usually be zero order, and it would just be flat. Okay, but I don't give you a zero order, and I've never seen the AP test give you a zero order on one of these. So it's going to be one of the two of them. Okay, tomorrow, because we're out of time, we'll do this second order practice. Okay, so far are we okay?